So first of all, exam 2 is on Canvas, and I made it due next week on Wednesday. Should be the 21st. It was going to be the 19th, and then, yeah. Cool. I have the topics. So instead of writing down the sections, I just wrote down what kind of problems. So first is discs. And washers. I have extra notes for this, and of course, examples, like I said. Okay, we did integration by parts. And then partial fraction decomposition, and we're going to put approximation with midpoints on the next test, on the final. Okay. Yeah, and I hope everyone's doing okay this semester. I hope doing class online hasn't been too stressful. I wish we could have, met up in a tutor lab, but there is a virtual tutor center, and of course you can meet with me. So let me know how things are going. I think we're ready. So I have notes about discs and washers, and then examples for all of the topics. Also notes about the exam. There's no time limit. You can do different attempts. So if you try today and then try again tomorrow, I will use the best part of your answer as like the work that I'm grading. You don't have to show work, but if you do show work, it helps me understand like how you read the problem, and it helps me grade the problem. Anyway, discs. So for both of these discs and washers, we're only going to go around the x-axis. So in that case, we're going to have volume as the integral from x equals a to x equals b. We'll drop a picture too. Of pi times the radius squared. And the radius will be your function. Okay, we'll put that volume down again, but I want to have a picture first. So here are your x values and y. And we have this piece. I picked pieces close to the x-axis. A, this is going to be B, this will be C. But when you rotate this way, and you have a little square in here, delta x. Okay. Integrate from A to B of pi times the radius squared dx. All right, we're going to practice this soon. The other part was with washers, and for this picture, we'll take this piece and kind of shift up a little bit. Okay, still, we're going around the x-axis. Here, and draw from A to B. With that piece, we're going to go over this way. Up and we're going to fill it with washers. We'll draw the pictures later with our examples. So this is a width of delta x. And we go around the x-axis. We'll call this C and D, but the integral goes from A to B. So integrate from A to B to get the volume. Okay, pi times the outer radius, and then subtract the inner radius squared. Okay, so we're going to do examples for discs first. So it would be find the volume of the solid obtained by rotating. We're going to kind of skip the rest of the sentence and put about the x-axis. Okay, so this is rotating the region enclosed by the given functions about the x-axis. And the functions are y equals x over 3, x equals 6, y equals 0. I'll be back. Okay. So back to drawing a sketch. This is going to be a straight or a line with a slope of 1/3, and it goes through the origin. Okay, x equals 6. In this equation, y can be any number, so any value for y, but x has to always equal 6. Y equal to 0, that means x can be any value, but y must always equal 0. So x can go left or right, but y has to sit right there. So it's this region here. And we'll rotate about the x-axis. So let's kind of copy that on this side. So it's kind of like a cone. And with this, we can put discs. The discs will go from x equals 0 to x equals 6. And we'll use the formula to get the volume of this solid. So let's draw a disc first. Okay, the radius goes from here to here, and that's a height of, let's see, when x equals that number, the height would be y equals x over 3. So from 0 6 of pi times the radius squared. So pi times x over 3 squared. Dx. Again, I may just leave the rest of the problem for you to do and go on. For example, let's see. Yep. Well, one more step, and then I think the rest would be okay for you guys. Let's bring out pi over 9. And then we're integrating x squared dx. Cool. So number 2, we're going to rotate about the x-axis. Okay. So the functions are y equals the root of x, y equals 0, x equal to 16. The root of x starts at the origin and goes up and over. Y equals, y equals 0. That's where x can go left or right, any number, but y must be 0. So right on that x-axis. Okay, x equals 16. So y can be anything, any number, but x must be over here at 16. So we're taking this region right here. And then rotate about the x-axis. So this one's kind of more of a cup, but on its side. So it's got another swoop. And then we swirled it around. And find the volume. Let's draw a disk in here before we set up the integral. So if we're filling this with disks, from x equals 0 to x equals 16, pi times the radius squared dx, where the radius goes from here to here, which would be a height of root x. Okay, so we're going to bring pi outside of the integral. We're integrating from 0 to 16, x dx. And I'm going to leave the rest for you to try if you'd like to. So I have another example for disks. So find the volume of the solid. By rotating the region about the x-axis. All right, we're taking y equals x cubed with x equal to 0, x equal to 1, and y equal to 0. So x cubed comes up, flattens out, and comes up again. X equals 0 means that y can be any value, but x must be over here at 0. X equals 1 is another vertical line. Where x equals 1. Y equal to 0 is sitting on the x-axis. So that's the region. So here. And then we rotate. So go this way and maybe draw. And we would put discs from x equals 0 to x equals 1. And let's draw a disc. Okay, so the radius goes from the x-axis to the function. So it's a radius of x cubed. It's an integral from 0 to 1 pi times x cubed, the radius squared. So x cubed and then squared. Dx. So pi, integrate from 0 to 1, and then x to the 6th dx. The rest is for you. Okay, so I'm going to move on to doing washers, but any questions about discs? Okay. So it's still a question where we find the volume of the solid obtained by rotating about the x-axis. So, and by the way, yeah, I picked questions that are related to test questions. So I just kind of tweak the number a little bit or pick a different part of the function. So as a good hint to that, especially like for this example, well, I'll just tell you in a moment, but use Desmos. So if you're not sure what your function looks like, just go and use the online graphing calculator and get your picture and know where the top function is and where the bottom function is. Okay, so back to this. We're going to have y equal to root x. Y equal to 1. X equal to 1. And also for that comment too about today's class, the goal for today is just to work on review 2, so questions for the test. All right, and then x equal to 4. Here. The root of x, we've drawn before. No problem. And also, anybody feel free to ask questions anytime. I'll check the chat. Okay, we're here. Y equals 1, which means x can be any number, but y has to always sit right at 1. So that's going to go through here. X equals 1 is right here. And then x equal to 4. 1, 2, 3, 4, and 3. So what we're doing is between x equal to 1 and x equal to 4. And then that line and that function there. So we're doing this section. I just want to let you know that I picked a similar piece of this problem, but shifted the x values over to right here. So be careful with your picture. Let's work through this problem. I'm just thinking, no, it's cool. If you have questions about what the region needs to be, like where the shading goes with your picture, just ask me in office hour or write an email. I can check your work. Okay, so right now we're going to rotate. So we'll go here. And kind of swoop. And we don't need this part. And I think it's kind of sweet too, just because. Okay, we're going to use washers, straw one. There. Get a little thickness. Okay, so with washers, we need to take the volume equal to x equals 1 to x equals 4. So I'm grading. Okay, pi, and then we have the outer radius squared, subtract the inner radius squared. So the outer radius, you go to your washer all the way to the outside edge where you have the root of x. So we're going to have root of x and then squared. Subtract. The inner radius goes from here to here, which is a radius of 1. Right there. That radius in, and it's also squared. And dx. So let's see, I have pi times, well, actually I have a, nope, never mind, I'm mumbling. It's pi times the integral from 1 to 4 of x minus 1 dx. Yeah, pretty much. I'm always going to pick questions where you rotate about the x-axis. So the radius is going to be what y is equal to, but be careful of what the outside radius is and what the inside radius is. So let's try another one. Going to take we're going to find the volume of the solid after rotating about the x-axis. So y equal to x cubed. The other one is y equal to x. X equal to 0. And then x equal to 1. Sketch. X cubed kind of goes flat and then up again, so we're going to have a swoop. Y equal to x is a line that goes through the origin, slope 1. I think they meet. I'm going to enhance the picture a bit. So they meet at 1. Okay. X equal to 0 would be this line. And x equal to 1. Let's go through here. So it's the slice between 0 and 1 right there, between those two functions. Okay. Rotate about the x-axis. So go this way, flat. Maybe give it a little bit of an opening or something. Okay, we're going to fill it with washers from x equals 0 to x equals 1. Draw a washer. Okay, so I want to take the volume and then integrate from 0 to 1. Of pi, and then we're taking the outer radius squared, subtract the inner radius squared. Dx. The outer radius is x, y equal to x. And the inner radius is x cubed. Okay, pi times integral from 0 to 1. We want to have x squared. Subtract x cubed squared. Dx. So pi times the integral from 0 to 1. X squared minus x to the 6th dx. And then I'm going to do one more example for washers and move on after that. first function is y equals e to the x. And then y equal to 1, x equal to 0, and x equal to 1. So we're sketching the region first. Y equals e to the x goes through the point 0, 1. And then y equals 1 will go horizontally like that. X equal to 0 will be here. And x equal to 1. So it's that piece right there. And we're going to take it and rotate it after I clean this. So there's going to be this hole in the middle, which means we need to use washers. So I'm going to copy this piece over to flat side and swoop. Let's draw the washer first. So we're going to hook something around. Inside and then the outside. Okay. And we'll give it a little width. Okay. So the integral goes from x equals 0 to x equals 1. Pi times the outer radius squared and subtract the inner radius squared. So the outer radius goes all the way to e to the x. And then the inner radius goes to 1. Y equals 1. Dx. So it'd be pi times the integral from 0 to 1. E to the 2x minus 1 dx. Oh man, we're almost out of time. We're gonna have to meet on Friday. So, I mean, we'll do more review problems on Friday. But the next part, or the next is integration by parts, and then we want to do partial fractions. So let's end it there and finish review 2 later this week. Oh, how would you integrate e to the 2x? Oh, use a u sub. Maybe we should, we have a few minutes. Let's do just that piece and then say goodbye. So scratch work. do a u sub and let u be 2x. U dx be 2. So you get du equal to 2 dx, or let's see. And then du over 2 equals dx. Just come over here. Okay. So we've got the integral of e to the u, and dx is equal to du over 2. Or 1/2 integral e to the u du. So I have 1/2 e to the u plus c. And then u is equal to 2x. So I'll put that in at the end. Okay, 1/2 e to the 2x plus c. Okay. And I think we're going to do, I can see it already, that we're going to do more use-ups like this next time. So, good question. Thank you, everybody. Let's say goodbye and stop recording.